Hi, this is Physics Unit 1, January 2015. Let's start. Number 1. A plane is traveling horizontally at a constant speed. It releases a package of supplies when it is in position shown. So, when the plane is in this position, it releases the package, and which of the following shows the path of the packages after released. So basically the plane is traveling horizontally. Initially it is traveling only horizontally at a constant speed, so it has a horizontal component of this, and it does not have any vertical component. Then when the package of supply is released, the supply moves downwards due to the attraction of gravity. The package accelerates downwards, so slowly the vertical component increases, right? So at this point, at the instant when it is being released, the vertical component is 0 and the horizontal component, the vertical component is 0, and there is only horizontal component, so there would only be a horizontal component in this direction. After a certain time, when the vertical velocity increases of the package due to the gravitational attraction, there would be a small vertical velocity too, so the resultant velocity would look something like this. So resultant velocity is this, so the resultant velocity here would be at this level. At this level the resultant velocity might be like this. So at this level the resultant velocity is like this. C sort of matches, and then afterwards the vertical velocity would increase a lot, since due to the action due to gravity the vertical component would start increasing and the horizontal component of the velocity would start to decrease a bit, since there is air resistance. So the resultant at that point would look something like this. So at this level the resultant would look something like this arrow. So at this level the resultant would something like this arrow. So it we can clearly say that C is the answer, since initially there is no vertical component, there is only horizontal component. The resultant velocity is only acting in the horizontal direction, and after a certain time the resultant direction starts to change its direction and starts to move downwards. The resultant velocity would just go downwards, so it is curved like this. Initially it has a higher horizontal direction, and afterwards the horizontal direction decreases and the vertical direction increases. So from this direction, from the rightwards, it goes downwards like this. So the correct answer is C. It is basically because the horizontal component is slowly decreasing due to air resistance, and the vertical component of the velocity is increasing due to the force of gravity. So the answer to this question is C. Number 2, a marble is dropped from the roof. It is dropped. So it is dropped, so the initial velocity would be 0 from the roof of a building and takes 3.2 seconds to reach the ground. The approximate height of the building is, so basically we need to use the SUVAT equations here. We have SU VAT, where S is the displacement, U is the final initial velocity, U is the initial velocity, V is the final velocity, A is the acceleration, and T is the time to reach the ground. So basically we need S, which is the height, displacement. The initial velocity is 0, since it says that it is dropped, so the initial velocity is 0. We do not need the final velocity. We have acceleration of g, which is 9.81 of the gravity of the earth, and t is time 3.2. So using s, u, a and t, we have s equals to ut plus half at square, where u is 0. So we can simply write that 0 into 3.2, which is the time, plus half into a into gravity. Gravity is acceleration. Acceleration due to gravity is 9.81, and time is 3.2. So the answer which comes is 50.22 meters, which rounds off to 50. So the answer is C. A box of weight 150 Newton is placed on an inclined plane. So this is basically the inclined plane. The component of the box weight along the plane is W. W in newtons is given by, so we have 15 degrees here and 150 newtons. So basically the answer is 150 sine 15, but there is a slight logic behind this. We generally need to memorize, since this is 150 sine 15 and this is 150 cos 15. You need to memorize it for the exam, but the logic behind it is, if we just redraw the diagram, we have something like this 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 is 90 degrees. We have a box here, and in this direction we have W and 150, right? We have 150 in this direction. So basically the thing is, if this is 15 degrees, we can draw a line perpendicular to the surface like this, and this angle would be 15 degrees. And since in this direction it's W, then parallel to this line we can draw a line like this. So this should also be W, right? This should be also W, and this would be 150. So basically we have a right angle triangle here. So the right angle triangle here is basically like this. We have 15 degrees here, hypotenuse which is 150, and the opposite side is W. So sine 15 is equals to opposite by adjacent, right? Opposite is W and adjacent is 150. So sine 15 degrees is equals to opposite, which is W, and hypotenuse, which is 150. So W would be equals to, if we cross multiply, we will get sine 15 degrees into 150, which again comes down to option D. Number 4. In which of the following is a vector fully described? So what is a scalar and what is a vector? So a scalar quantity is anything that has only magnitude but no direction. For example, time. Time, we have magnitude, for example 5 meter, 5 seconds, 10 seconds, 15 seconds, 100 seconds, or 1 minute, 50 hours, 30 days, something like this, right? We do not have any direction here, we only have a magnitude. But in a vector quantity we have both magnitude and direction. For example, velocity, we can say that an object is traveling at 15 meter per second due north or due east. So 15 meter per second is the magnitude, and due east, due north, 30 degree due south, these all are directions, right? So a vector quantity is basically which has both magnitude and direction. So part A says that a car travels north, it only has the direction, no magnitude. A crane moves a load 20 meters east. So this is correct because 20 meter is a magnitude and east is a direction. So the correct option is B. C says that a train travels at a rate of 35 meter per second. This is a scalar quantity since it does not have any direction but only has magnitude. The magnitude is 35 meter per second. And a lift move upwards with a kinetic energy 2.5 kilojoules. This is a sort of a trick question since it says that upwards is a direction and 2.5 is the magnitude, but it should be a vector quantity, right? It is not a vector quantity since kinetic energy is a scalar quantity. Energy is always a scalar quantity, so this is also not correct. So the only correct answer for number 4 is B. Number 5. A ball is thrown vertically upwards with a velocity of 3 plus 3 meter per second. So basically we have a ground here, and above the ground we have a ball which is being thrown upwards. This is the ball, and this ball is being thrown upwards with a velocity of plus 3 meter per second, right? So basically the thing is, if we have a velocity 3 plus 3 meter per second, there is a force acting in the opposite direction, right? The force due to gravity. So the force due to gravity, since the force due to gravity is downwards, since F equals to m into a, since F is the resultant force, m is the mass, and a is the acceleration, the force is downwards towards the ground, which means that it is in the opposite direction, right? It is in the opposite direction, and in the opposite direction, since there is a force in the negative direction, there should be an acceleration in the negative direction, right? So basically at maximum height the acceleration of the ball is, so it doesn't matter where ball is, always the acceleration would be minus 9.8 meter per second square, since the velocity of the ball when it is going upwards is positive, anything in the downward direction will be negative, right? So a negative direction is downward. So basically the ball would go at 3 meter per second, then it will decrease to, for example, 2, and then 1, and then 0. The velocity of the ball would be 0 at the topmost point, and then the velocity would again starts to increase. The magnitude would increase, but the actual velocity would decrease. Why? It is because it will become from 0, it will become -1, -2, and then -3 here when it reaches the ground. Basically, anything in the upward direction is positive and anything in the downward direction would be negative. And since there is always a constant force acting in the downward direction, it would be negative. And since it is due to the of attraction due to gravity, the gravitational field strength is 9.8 Newton per meter. So basically the acceleration would be minus 9.8 meter per second squared. So the answer to number 5 is D. Number 6, a ball is thrown vertically upwards. So basically we have a ground here and the ball is thrown vertically upwards. It goes up and again it goes down. So it reaches a maximum height, moves downwards, and is caught by the thrower at time t. So basically it goes up like this, it reaches its maximum height. So at this point the kinetic energy is 0, as since kinetic energy is equal to half mv squared, right? Half mv squared, since there is 0 velocity, there would be 0 kinetic energy, and when it moves down again, the kinetic energy again increases, right? Since we have ke is equal to half mv squared, we can clearly say that the velocity is v squared is proportional to ke, right? Since it is proportional to ke, it means that initially when it is thrown vertically upwards, there is a kinetic energy since the velocity is maximum, and then slowly the velocity decreases, right? The velocity decreases due to the downward deceleration due to gravity. So at this point the velocity is 0, so the kinetic energy is 0. So basically initially the kinetic energy is maximum, so it is here something like this, and then when it is at the topmost point, the kinetic energy is 0. So it goes to here, and then it then again starts to increase, right? The kinetic energy becomes 0 at this point, and then it again starts to increase. The kinetic energy increases because the velocity increases due to the gravitational pull. So again the kinetic energy increases. So the only graph that matches with this diagram is B. So the option is B. Number 7, a material that is able to undergo plastic deformation under compression is said to be. So basically a plastic deformation is, so part A says that it's brittle. So brittle is basically a property which breaks easily, right? Due to brittle, it breaks easily. So it is not thing that would undergo plastic deformation, right? Brittle is something that would break before it goes to plastic deformation. So A is not correct. B says that ductile. So ductile is basically it undergoes plastic deformation but under tensile force, not compression. So tensile is basically we are pulling something from the opposite ends in the opposite direction. So basically ductile is basically pulling a metal opposite directions till it becomes a sort of a wire, something like that, or pulling a rubber band or something like that. So B is not correct since it is not under compression, it is under tensile strength or tensile force. C is not correct because hard is basically the property that prevents indentation or any kind of deformation, right? Hard is basically property that is used in mobile phone glasses or gorilla glasses. We have gorilla glasses, right, in iPhones, which guarantees that won't be any scratches from the dust particles or the car keys or anything that we have in our pocket and our phone together. Option D is the only correct answer since it undergoes plastic deformation and under compression. So the correct answer is D. Number 8. A girl of mass 30 kg and a boy of mass 45 kg. Boy of mass 45 and the girl has a mass of 30. So the lighter weight is the girl. Sits on a frictionless floor holding the two ends of a rope. The ball pulls on the rope. The girl moves towards the boy with an initial acceleration of 3 meter per second squared. So basically, so we have a boy here and we have a girl here. So this is the girl and this is the boy. So the boy pulls on the rope. So this is the rope, right? This is the rope, and the boy pulls on the girl with a force which causes the girl to move towards the boy, right? Moves towards the boy. So basically, what would the boy do? The boy would move towards the girl too. This is because since there is a momentum of the girl towards the boy, there should be an equal and opposite momentum of the boy towards the girl. So the answer would either be A, B, or C. So basically, there would be equal and opposite momentum, right? Since we know that P equals to mv, so the mv of boy would be equals to the mv of the girl, right? The mv of the boy would be equal to the mv of the girl. So basically, the mass of the boy is greater. So since the mass of the boy is greater, the velocity has to be lower. The velocity of the boy has to be lower. Since there is a lower velocity of the boy, the acceleration would also be lower than the girl, right? Girl has a lower mass. So lower mass means that she would have a higher velocity than the boy. So the boy would have a less than 3 meter per second initial velocity. The initial velocity or acceleration the boy should be lower than the girl, and since the acceleration of the girl is 3 meter per second, the answer should be less than 3 meter per second. So the only answer that is applicable for number 8 is B. Number 9. A thin wire of uniform cross-sectional area is stretched by an increasing force. The corresponding stress-strain graph is shown. So this is the stress and this is the strain. Stress is basically the force and strain is basically the type of extension. Typically it's the extension. So point W, X, Y, and Z are shown on the diagram. Select the row of the table that correctly identifies the yield point, the limit of proportionality, and the elastic limit. So basically the thing is, we can clearly see that the line up to W is proportional, right? It is a straight line, but after W it curves out. So basically W is the limit of proportionality, where up till W the stress is proportional to the strain, and so the gradient is constant. So this is the limit of proportionality, and after that X is basically elastic limit. So the elastic limit is basically point after which if we remove the stress, it won't return to its original position. It will get permanently deformed. So till X, if we exert a force like this, and if we remove the force, it will go back to its original position. But if we go till, for example, Y, it would return like this. It would not return to its original length. The original length not be seen anymore. So X is the elastic limit and Z is the yield point, because just after Z the graph just curves out like this. It does not, the stress increases, the strain does not increase, it just decreases, right? So Z is basically the yield point. So W is the limit of proportionality, X is the elastic limit, and Z is the yield point. You just need to memorize the graph. It really comes handy if you just remember the graph and keep the graph in mind. The only correct answer to number 9 is B. Number 10. A force is applied across the ends of a spring and the following force extension graph is drawn. 3 points P, Q, and R are marked on the graph. At point Q, the applied force is 0. So at point Q, the applied force is 0. So when there is no applied force, the spring looks something like this, right? In the table below, the spring is represented by diagrams drawn to scale. So these are the springs. The spring at Q is represented by this. So as I have just labeled, select the row from the table that correctly represents the length of the spring at position P, Q, and R. So basically at R, the force is in the positive direction and the extension is also in the positive direction, right? So it is being extended, the force is it is being extended. So basically if the spring is like this, if we pull the spring, it will look something like this, right? So at R it is being extended. So basically the answer is this or this. So let's see B. So option B says that it remains as it is, and option A says that it is being compressed. Option A is correct, because we have to notice here is that this direction, since this direction, the positive and positive direction is extension, then the negative and negative direction is actually compression. So basically here at point P, it is being compressed. So the only correct option is A, since at P the graph is being compressed and at point R it is being extended, and at point Q no applied force. So the only answer to question 10 is A. So that was the end of the paper. If you find this paper useful, the explanations useful, please leave a like. This really helps the YouTube algorithm and it will help video to reach to other people, right? So guys, you've got this. Good luck for your exams. Take care.